Hi, in this video we're going to be working with derivatives and the power rule, and this video is part 5 in a series, so let's get started with these problems. So here we're working with f of x is equal to 1/3 times x cubed. So how do you take the derivative of this when you have the exponent on the outside? So what I would do is I would actually work the exponent in, so let's go ahead and do that. So I would do f of x is equal to 1/3. I'm going to cube that, and then I'm going to cube the x. So then I would get f of x is equal to 1/27 times x cubed. And now I'm ready to take the derivative. So the derivative of f of x is equal to 1/27. And remember, when you're dealing with the power rule, you bring down the 3 and you subtract 1 from the 3. So let's do that. First thing is bring down the 3. So it's going to be times 3. Then I'm going to subtract 1 from the 3. So it'd be 3 minus 1. And so the answer to this problem is the derivative of f of x is equal to, oh by the way, 3 goes into 3 once and 3 goes into 27 9 times. So this is going to be 1/9 x squared. And that's your answer. So the derivative of f of x equals 1/3 times x cubed is equal to this down here. So let's go on to the next problem. Now, how do you take the derivative of a negative exponent? Well, it's exactly the same way. So now we got y here. So the derivative of y. Now you could write this a couple different ways. You can say the derivative, or dy dx, so the derivative of y with respect to x. And then over here, so the first thing you do when you're dealing with exponents is you bring down the exponent, so we're going to have a negative 1/2 times x to the negative 1/2, and remember, you have to subtract 1 from up top, so minus 1. So another way you could write the derivative is just, in a simpler way I think, is just to write this slanted line up top. So the derivative of y is equal to negative 1/2 x minus 3/2. And that's the answer to that. And that's how you do that. So let's go on to the next one. Now what do you do when you got this? You have it looks kind of kooky. So how would we do this? Well, it's the same thing. Don't let the b or the omega fool you or throw you off. It's just, you could put any variable you want in there. You'll usually see f of x or y, and you'll see x over here, or maybe some other variables. So don't let that throw you for a loop. So let's get started on this. The first thing I want to do is I want to rewrite this the sixth root here. So I'm going to say b is equal to omega to the 1/6 power. And that's what this means right here. So let's take the derivative. So the derivative of b is equal to, and then here again we're going to bring down the 1/6. So bring down the 1/6, and then you have 1/6 up top, and you subtract 1 from that. So, and by the way, you can rewrite this as db over d omega, or the derivative of b with respect to omega is equal to 1/6 omega over negative 5/6. And that's how you would do this problem. So I hope you enjoyed the video. If you do, please like it. You can do that down over here. And I'll be coming out with another video. It's similar on this, and it deals with some other odd looking derivatives that you're probably going to encounter in your classes. So please subscribe, check them out. If you like the video, please like it, and good luck in your classes.